Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper from the Hugging Face Trending List, published on August 22, 2025, just 3 days ago. The striking result is a new way to adapt agents without changing model weights, delivering 87.88%, pass at 3 on GAIA validation, and 79.40% on the test set, plus strong gains on deep researcher and out-of-distribution tasks. The paper is titled AgentFly, Fine-Tuning LLM Agents Without Fine-Tuning LLMs, and the implications for agent training are quite significant. Beyond benchmarks, the method uses memory-based online reinforcement learning to continually improve through retrieval and rewriting, keeping costs low while scaling to deep research tasks. Also, the authors shared an open-source repo. You will find the Memento codebase with a planner executor agent, a memory-based case bank, and a full MCP tool suite. There are client and server folders, interpreters for code execution, SEER XNG search setup, quick start instructions, config via .env, and benchmark results. Earlier, I outlined the high-level idea and headline numbers. Now Figure 1 summarizes results across datasets and settings. The top left panel compares validation and test levels on GAIA, where the method leads consistently. The top right panel presents an ablation showing planning and case-based reasoning add clear gains across deep researcher, simple QA, and HLE. The bottom left panel plots continual learning, which rises over iterations because memory reading and writing improve retrieval. The bottom right panel reports out-of-distribution gains with several 5 to 10 point boosts. The previous figure focused on results. Figure 2 now shows the mechanism, a graphical model of the memory-based Markov decision process. The diagram presents states, actions, rewards, and memory nodes, with red arrows for environment dynamics and blue arrows for agent behavior. The key flow is, the agent retrieves a case from memory, selects an action with the large language model conditioned on that case, receives a reward, and then writes the new case back, which closes the learning loop. This structure enables continual adaptation because memory reading and writing directly guide future retrieval and action selection. Alright, the previous figure outlined the MMDP loop. Figure 3 shows the working architecture, which alternates case-based planning and tool-based execution, so the agent can plan, act, and learn from feedback. The left stage maintains case memory with read and write that update the estimated Q value and retrieve helpful past cases. The center tracks subtask memory, so planning and replanning stay organized. The right stage routes subtasks through an LLM executor to the MCP tool stack, returning results to memory. Okay, the previous figure covered architecture. Table 1 now compares methods across 7 open domain question answering datasets. The table reports both F1 and PM, and the row for AgentFly shows the strongest average, 66.6 F1 and 80.4 PM. The gains are broad because scores improve on natural questions, trivia QA, hotpot QA, and more. The contrast with prompt-based and training-based baselines highlights that memory-driven agents can compete with outweight updates. So wrapping up, 2 takeaways stand out. First, memory-based online reinforcement learning lets a frozen planner learn on the fly, using retrieval and rewriting to improve without costly weight updates. Second, the planner executor plus casebank scales to deep research and generalizes out of distribution. That is it for the AI Research Roundup. I am Alex. Thanks for listening.